So now I have a function that takes a number, an integer, positive integer, and spits out a score. And so what we could do is we could make a data frame that had the integers, I don't know, how deep did you say you took the depth? Like 100? Yeah, so we could do nums equals range 101, throw that one on there. And then I could have scores equal depth to score in or in and none. And so this range operator makes this be numbers from 1 to 100, and scores is now going to be the score that we got for each of those. So now I'm going to make a data frame, and I'm going to use the fact that you can construct a data frame coming from a dictionary. When you create a pandas data frame, dictionary is actually just one of the raw things you can do to create it. So you'll see here that what I have just in the regular documentation for creating a data frame is that you can do a dictionary where you give it the column name and the data that should be in that dictionary, and then the column name and the data that should be in that column. And then 1, 2 should be the data in column 1. And you can see that here. Dictionary just has something with a colon followed by something else, comma, something, and a colon followed by something else. And this is like a function. This is a mapping. So call 1 should be mapped to 1, 2, and you can see that here. Call 2 should be mapped to 3, 4, and you can see that here. What we're going to do is we're going to create a new data frame where we have the columns being so I'm going to have depths being nums, and let's say depth, and the score column will come from the scores thing that we defined earlier. And I need to put these curly braces so that this is actually a dictionary. So it's parentheses, curly brace, then what you want to work with. You are allowed to line break inside of these things after a comma, and sometimes that makes things more readable. So now if I look at my df.head, I see what I just did. I just took these depth is this 1 to 100, and then the score column came from this, taking this data that we did in the list comprehension and passing it to the scores, passing it to the score column name. And this tells me at depth 1, my decision tree had performance of 78%, which that means there's one variable that splitting on that gave you 78% accuracy of spam or not. That's a really important variable. 2, 3, 4, 5, and we could see it. This goes down to 100, but we see that we've plateaued. Like we're not continually getting closer and closer. And in fact, that means that this data is perfectly split out, or at least it can't get any better. In your function, did you have this thing where you did the fit X train, Y train? So make sure that your depth to score, yeah, so you need to be sure that you're doing 3 things inside this function. You need to create your decision tree, you need to fit it, and you need to score it. It's really good to know how to do something like this, where you're taking something that you did previously and you realize, well, wait a minute, I want to do this for 50 different parameter values, but I don't want to sit there and do it 50 different times. Tool for this called GridSearchCv. And what GridSearchCv does is it takes lots of different possible options and explores how those options influence performance. So what you need to have is you kind of need to have a picture of a grid that you'd like to case here with just having this one depth parameter. But in general, we can take anything that is allowed to change on different decision trees, and we can change it and have the computer search the different possibilities. At the documentation in sklearn for GridSearch. And again, it's better to scroll through the options and get to we have here a data set that's being loaded. For us, we already have our data set loaded, so we don't need to do that. We already have our data set loaded. This dictionary of parameters is something that we will input. You see how it says parameters kernel, and then it has the tuple linear and RBF, and it has C, and it has the list with 1 and 10 in it. Create a classifier inside, which is for us is going to be our decision tree classifier. And then our CLF object is actually our GridSearchCv on our classifier with our parameters that we fit. So I'm going to, from sklearn.model selection, import GridSearchCv. So let's go back to the sklearn decision tree classifier and see what are our possible things we could change. So we could change our criterion between Gini, entropy, and log loss. We could use, we could change max features. We could change max leaf nodes. We could change the max depth. So why don't we experiment just with max depth, which we've already used, and then also see how changing the criterion could adjust things. So I'm just going to build a GridSearchCv over these two things. Looking at the syntax I had before, see, I need to create parameters, and my criterion parameter, I'm going to explore between Gini, entropy, and log loss. So first I have my key, and then I have the options that that key could take. And then I'm just going to do max depth to be what I had as my options before, to be all of nums. I'm going to create a clean decision tree classifier object that I haven't yet fit on anything. And then I'm going to create my classifier to actually be this blank decision tree object along with the parameters. So this first dictionary of parameters tells it what I want it to explore and what I want it to explore over. I want it to explore criterion to be Gini, entropy, or log loss. And I want it to explore max depth to be over this list from 1 to 100 that we called nums. So how many different decision trees is it going to build? 300. Three for this, and then we had 100 for the other one. So we're going to have a, and then we do call clf.fit train y train, just like we would on any other classifier. So this trains 300 different decision trees. Each decision tree has its own unique. It's normal that sometimes these things take a little bit. What we see out of this is after you call this, what you get is a dictionary, and there's a results dictionary that you get. Okay, so CV results, let's see what that looks like. So clf.cv results. Well, so this is a dictionary, right? And I think my life will look a lot better for myself if I cast it to a data frame. So isn't this beautiful? It's like we've almost come full circle, because now I have, of these 300 different decision trees that were built, I have a data set. This is an honest to goodness data set. And if I did not understand very well how the decision trees might work on this data set, then this gives me some idea. So I can take this data set and I can start asking questions, just like I did with the Titanic survival. I could start plotting the data. I could start seeing what the average values of the data were for different things. So for instance, I think I could call Seaborn the mean test score with the hue being the param criterion. So if I wanted to, I could call sns.scatterplot data equals results df. I could have X being the parameter of max depth. I could have Y being the mean test score. And I could have the hue being the param of the criterion. Okay, so tell me what you see here. So these are very comparable. There is a little bit of randomness. You see that like with entropy, something like all three metrics give very high performance. So if we see that there's this big jump around 5, we know, well, we definitely shouldn't make it any bigger than that. Like we're just making it slower and adding more size. Or adding more. We could also look at another thing that would be helpful in addition to the score is the performance time. So we could do the same thing, but we could do it with, we could have our Y be how long it took to train, because it does give us that information as well. It tells us how long it took to fit the data, how long it took to score the data. So let's change this to be mean fit time. So notice Gini takes longer to take. It's not taking anybody very long, but it is taking Gini about twice as long as the other criteria. So if you're in a really tight performance scenario, that would be something you could take into account.